guys, today we discuss about rotating motion, which is projectile motion, in which we show a motion of particle in two directions. One is along y-axis, one is along x-axis. So let's start its definition. If a particle is projected with an angle with horizontal direction with some initial velocity, so basically we throw a particle from ground with an initial angle theta from horizontal and with initial velocity v. Now first heading is ground to ground projectile motion, in which first of all we draw the diagram of this one, and second we take component of velocity along one is along y-axis, one is along x-axis. Now we take the component of the velocity, one is along y-axis and one is along is x-axis. So in x-axis the initial velocity is u cos theta. We know the component of both of them. I will write here u sin theta and u cos theta, and in y direction the velocity is u sin theta, and in x-axis there is no force as you told about previously, so there is no acceleration, and in y direction gravitational force is acting on the particle. So we know this above direction is positive, we take it positive, so the force is in opposite direction, so we take it as minus g. Now from this one we calculate three time, range and maximum height of the particle. So let's start. We know first of all is time of light. We know there is no displacement in y direction. See, particle moves. Let's see only the y, what happened in y direction. Particle move upward and again come downwards. So in y direction total displacement 0, because initial position is here 0 in y, that 0, and final position is also 0. So from this one we find out time of light. So we use this equation because we read out in previous chapter 1D motion. So from that one I will take this equation. So we know in y direction displacement is 0, so here is 0 equals to, we know uy is y, uy is u sin theta, u sin theta dot t, we have to find out time of flight, sorry, t plus half, we know ay is minus c t square. So this is a quadratic equation in which variable is t. So let's solve it out. When we solve it, this will come like this: gt square minus 2u sin theta into t equals to 0. We take out t common, gt minus 2u sin theta equals to 0, in which first variable, because we know this is quadratic equation, so we have two roots. First one is 0 and second was take 2u sin theta upon g. So we know there when we throw particle, so t equals to 0 is not possible, so we have to take t equal to u sin theta. So this one is equals to our time of flight. Now second one is maximum height. So we take this equation, v square equal to u square plus 2as, in which v is final velocity, u is initial velocity, a is acceleration, and s is displacement. So we take this one is in y direction. So vy square equal to uy square plus 2ay sy. We know displacement is also a vector quantity. So from this we have to write final velocity. So let's see here. If we throw a particle, there is a continuously force acting on a particle in y direction, which is gravitational force. So at maximum point the velocity of particle is 0. So here the final velocity in y direction is 0. In x direction all the point on the motion is same, u cos theta, everywhere is u cos theta. It will not changes because there is no force in x direction. So final velocity is 0. Initial velocity uy we know is, what is uy, u square sine square theta plus 2. We know what is ay is minus g. As y is displacement in y direction, which is h. So from here we solve this equation and we get 2gh equal to u square sine square theta h equal to u square sine square theta upon 2g, which is maximum height of the particle in its whole motion. Now third one is its horizontal range. From A to C. So this one is very easy. We take the displacement in x direction, which is xy sx equation, second equation in which we read in 1D motion, sx equal to ux t plus half a t square ax. So sx is range, which is r. Ux, we know what is ux, u cos theta. T, which is time of flight, we know what is time of flight is t plus half. In x direction there is no force, so there is no acceleration, ax is 0, t square. R equals to u cos theta. We know time of flight, we have to see previously. First one is 2u sine theta upon g. This is our time of flight. So range is r equals to 2u square cos theta sine theta upon g, which is, and we know 2 cos theta sine theta is sine 2 theta, u square sine 2 theta upon g. This one is our horizontal range of the particle. So we have to do for our equation from the point of view of the exam. We have to add some points. First one is, what happens if we increase the angle theta? Our initial velocity is same as in all the case. What happens if we increase the theta? So let's see in what happen in time of flight if we increase the theta. So let's see what happen in sin theta 0 to 90 degree. Okay, so 0 to 90 degree, the graph of the sin theta is like this. We know graph of the sin theta is like this. So this one is 90 degree, 180 degree, 0 degree, pi. Okay, pi by 2. So from 0 to 90 degree, sin theta is continuously increases and is maximum 90 degree. So if we throw a particle from 0 to 90 degree, so its time of flight is continuously increases. After 90 degree, we increase theta more, so it changes direction, and this will happen in that direction. And again, it's increase theta from 90 degrees. So after that, time of flight is decreases. This one is same as in this is also same for maximum height. If increase theta, sin theta increases, so maximum height is increases. So there is a different case in a range. So let's see the graph of sin 2 theta. Here is pi by 4, this one is pi by 2, this is 3 pi by 2 for sin 2 theta. Because when we put pi by 4, this one is 2 theta is become pi by 2, so pi by 4 is maximum. So what happen in range from 0 to pi by 4, its range increases. After that it will decreases. We have a question. A particle is projected with the initial velocity 50 meters per second, making an angle 37 degree with the horizontal from ground. So first of all, we have to draw its diagram. So particle is thrown from ground, so it's after projectile motion is also fall down on the ground. So this one is 50 meters per second, theta equals to 37 degree, y-axis, x-axis. So we have to find out time of flight, maximum height and range. So here in x direction, x-axis, velocity is ux equals to 50, sine 37 is 435. X direction, its a component in x direction is 50 cos 37 degree, and in y direction 50 sine 37 degree. So this one is 50 cos 37 is 4 by 5, uy is 50 and sine 37 is 3 by 5. So from here we get 40 meter per second, and here we get 30 meter per second. Ax, there is no selection in x direction, we know that there is 0. In y direction is minus g, which is minus 10 meter per second square. So now first of all is time of flights. So we have a two choice, either we use formula, direct formula, or use a 2D and 1D equations for both directions. So from the point of examination of view of J advanced and mains, we have to direct use the formula, which is first one is time of flight, which is 2u sine theta upon g. So here 2 initial velocity is 50 meter per second, and sine theta, sine 37 degree is 3 by 5, 5 into 10. So this one is sorry, 6 seconds. Now second one is maximum height, u square sine square theta upon 2c. U square initial velocity is 50 whole square, sine square theta, sine theta is 37 degree, which is 3 by 5 whole square upon 20. So we have to solve this one. Is we will get let's solve it, 9, 20, 25. So this one is we will get 45 meter. We have to solve this one, it's easy. After 100 is 9, 24 and it is 45. Last one is range, which is u square sine 2 theta upon g equals to 2u square sine theta cos theta upon g. 2 into u, what is u square is 50 whole square, sine theta is 3 by 5, cos theta is 4 by 5, and greater is 10. So from here we get 2.2500 into 4 12 250. From here we will get 240 directly meter. Okay, now this is the second part of the previous question. Find the position of particle after 3 seconds and 5 seconds. So particle start from origin 0, 0, and we have to find the position of a particle. So let's start. So here the formula are not directly not work, so we have to use of 1D. We have to use a basic equations. So position of particle at 3 seconds, first of all, t equals to 3 seconds. We have to find position of particle on x-axis. Where is it? First of all, for x-axis, so we have to use formula as x equal to ux t plus half ax t square. Here t equals to 3, ax equals to 0, and ux is 50 cos 37 degree, which is 40 meter per second. So as x equals to, this is also comes to I vector, because it is a displacement, so it is a vector quantity. Ux is 40 into 3 plus half x. Here x is 0, so it is 0. It is 120. For y-axis, sy equals to uyt plus half ayt square also comes to j. Here s equals to it is 30 meter per second. Sy 30 into 3 minus half into 10 into 9, 3 whole square 9. This one is 90 minus 45 also comes to 45 j. So the position of particle at 3 equal to 3 second, t equal to 3 second is 120, 45. For t equals to 5 second, second part. Sx equals to 40 into 5 I cap. For sy 30 into 5 minus half into 10 into take 5 whole square 25. So it is come to 150 minus 125. This one is 25 j cap. So position of particle is this one is 200, 25. Now this is the third part of previous question. Find the magnitude of average velocity between 0 to 3 second and 0 to 5 second. First of all, we know that average velocity equals to change in displacement upon change in time, which is del x upon del t. Now first part is 0 to 3 second. So we have to find the change in displacement between 0 to 3 second. So at t equal to 0, the position of particle is 0, 0 origin. At t equal to 3, we have to find in previous question the position of particle. So at t equal to 3, position of particle is 120, 45. So average velocity is 120 I plus 45 j minus 0 I minus 0 j, which is nothing, upon time. So this is average velocity, but in this question we have to find out magnitude. So the magnitude is, this one is 40 I plus 15 j. So magnitude is under root of 40 whole square plus 15 whole square, which is 600 plus 225, which is 1825 meter per second. Now the second part, position of particle, magnitude of average velocity between 0 to 5 second. So at t equal to 0, position of particle 0, 0, and t equal to 5, position of particle is 200, 25, which we find out in previous question. So average velocity, I write directly, is 200 I plus 25 j upon 5, which is 40I plus 5j upon 5. Sorry. So magnitude of average velocity is 1600 plus 25 1625 meter per second. Now this is the second equation. A ball is projected with initial velocity 40 meter per second, making an angle 60 degree with the vertical upward direction from the top of 60 meter high building. So here the angle is given is 60 degree with vertical. So this one is 30 degree with horizontal. We know this is 90 degree. So resolving them we get 30 degree. Now first part of this question is find the time after which it hits the ground. So first of all, here the direct formula are not work. So we have to use from basic. Okay. Now first part of question is find the time after which it hits the ground. So what we do? We take a equation sy equal to uyt plus half ay t square. Here upward direction is positive, okay, and downward direction is negative. So the displacement is below the projection, so it is minus 60, opposite direction, because upward direction we take positive. Ui here is 40 sin 30, which is 20 into we have to find out time period, minus half into 10 into t square. So this is a quadratic equation. T square 5t square minus 20t minus 60 t square minus 40 minus 12. So from here we get two roots, two value of time which it hits the ground, which is not possible. So only one value we have to find, we have to take from both of them. Now t square minus 60 plus 2t minus 12 equals to 0. Sorry. t minus 6 plus 2 t minus 6 t plus 2 t minus 6 t equals to 2 and t equals minus 2 t equals to 6. So time is negative, not possible. So t equals to 6 is the time which the particle hits the ground, ball hits the ground. So this is our first part of second question. So second part is distance of ball from a building on ground. So we have to find this one, distance. So what we do? We take equation for displacement of particle along x-axis. We know the time period, we know the initial velocity, we know the acceleration, what is it. So we have to use this equation in x direction. So Sx equal to ux t plus half ax t square. So Sx, which is d, we take as d, equals to ux is this one 40 20 root 3 where ax is 0. So distance from the building is 20 root 3 meter into 6. So the complete distance is 120 root 3 meter. Now third part is find the maximum height from the ground. So basically we have to find out where the velocity of particle in y direction is 0. So basically we have to find that position of particle, because this is a maximum height, because there is a no velocity in y direction. So this is the maximum height of the particle. So I think we have to use both of them, formula or basic work everywhere, but formula not work here. Basic and formula both are work. So we have to use direct formula, because we take assume that this is a ground and it is a maximum height, ground second, and it is maximum height from here. So this is also maximum height from this ground. So we take direct formula as equals to u square sin theta upon 2g, sin square theta upon 2g. So what is u? U is 40 meter per square whole square. Sin 30 is 1 by 2 whole square upon 2c, which we get 80 meter. Now this is the second type in projectile motion, inclined plane projectile motion. So here the difference is we have to rotate the x-axis. First of all, in previously we have to like this one. Now we will rotate to the like this one. So there is no difference in that. We have to do this one. So here the difference is the gravitation force acting on the particle. The direction will change in this projectile motion. So the gravitation force is downward. So we have to take component of both of them, one along x-axis, one along y-axis. So this one alpha, this one is 90 minus alpha, and this one is alpha, because it is whole is 90. So from here we take the component g cos alpha, g sin alpha, and now we have to find same thing, time of flight, maximum height, and the range, which is this one, this range. Now first of all is time of flight. So in x-axis we take the component of u is, this one is theta, so u cos theta, and here there is a gravitational force which is acting in negative direction of x-axis, so it's minus g sin alpha. Here for y-axis we take the component is uy sin theta, and gravitational force is minus g cos alpha, which is in negative direction of opposite direction of negative direction of y-axis, so is minus g cos alpha. So here first of all is time of flight. So the same concept we have to take the displacement in y direction. In this also is, in this position is also 0, because this is y, this is x. So the particle position is in y direction is 0 in whole motion. The displacement is 0. So we have to take sy equals to uyt plus half ayt square. Now sy displacement of particle in y direction in its complete motion is 0, equals to uy. We know what is uy is u sin theta t minus half ay is minus g cos alpha t square. So this is the quadratic equation. From here we get two commons. First of all we have to resolve this one. So g cos alpha t square minus 2u sin theta t equals to 0. Now we take t common, t g cos alpha minus 2u sin theta equals to 0. T equal to 0 not possible, because there is a projectile motion, so within 0 second it is not complete. So we have to take another one. Time of flight, which is capital T, equals to 2u sin theta upon g cos alpha. There is nothing different but g cos alpha. Cos alpha is come here because we have to take component of gravitational force here. That's why there is a little bit change. Second is maximum height. So we have to take the same concept which we take in previous one. The position where the velocity of particle in y direction is 0. So we take that equation Vy equal to uy whole square plus 2as. So here Vy is 0, position of velocity of particle in y direction 0. So this is the maximum height. So here 0 equals to uy. We know what is uy. U sin theta u square sin square theta minus 2 a is g cos alpha, and s is maximum height which we want to get. So we got the maximum height is h equals to u square sin square theta upon 2g cos alpha. So this is our maximum height from the ground as well as from the inclined plane. Now third one is range, which is this one a to c. So we have to find out the range. So from this one we have to use displacement in x direction. So sx equal to ux t plus half ax t square. So sx is range and ux is u sin u cos theta into t, which is time of flight, so it is capital T, minus half ax is minus g sin alpha, g sin alpha. We have to take previously minus directly t square. So r equals to u cos alpha. Here t is 2u sin theta upon g cos alpha, which we find previously, half g sin alpha. T square is 2u sin theta upon g cos alpha whole square. So from resolving this one, complete one, this one is 2u square sin theta upon g minus half g sin alpha 4u square sin square theta upon g square cos square alpha. Here g is got this one, and now we have to solve this whole complete one. It's 2u square upon g 2u square upon g and g. Sorry, this one is cos theta, so it will not cancel. Here alpha cos theta cos alpha. So we have to take cos square alpha outside, cos square alpha inside is sin theta also, because it is common in both of them. Now cos alpha cos theta minus sin theta sin alpha. So this one is 2u square sin theta upon g cos square alpha. So this one is cos alpha plus theta, cos alpha plus theta. We know the formula, we have to know this one in trigonometry. So this one is our range. And secondly, I recommended you that you have to find using this equation always range in inclined plane. In every equation you have to use this one, the formula directly, not this one, because this is very complicated. Sometimes we forget this one, so it's better to we have to use direct equation, this one, because it is basics. Second part is down the inclined plane. So first of all, we see what changes in this one. Previously ux is u cos theta, so in this one is us u cos theta. Previously uy is equal to u sin theta, so in this one is also ui equal to u sin theta. Ax is previously minus g cos alpha, here ax is g sin alpha, so change is here. Ay is also same as previously up the incline. So what is changed? Only ax. So first of all, we have to find the time of flight. In time of flight, there is no use of ax. We use only ay because we use equation this one in equation in y direction. So in y direction, the all force component, velocity component are same as in previous only. So time of flight is no change. Same maximum height is no change. The change in range of in range we use this equation sx equal to uxt plus half axt square. So sx is our range, ux is same as in previously we have to find is u cos theta. Time of flight, we know time of flight is 2u sin theta upon g cos alpha plus half ax is g sin alpha and t is 2u sin theta upon g cos alpha. So change is only minus sign. In up incline, here is minus. So by resolving all of them, we get the range is here. Previously we got range is cos theta plus alpha. Here we got the range is theta minus alpha, because I will show you the difference. Here 2u square sin theta cos theta, we take sin theta common, and below we take g cos alpha square common. So above cos theta cos alpha plus here 2 4 square u square, here is sin theta and sin alpha. So cos theta cos alpha plus sin theta sin alpha is cos theta minus alpha. So here r equals to 2u square sin theta upon g cos alpha cos theta minus alpha. Change is this one, only range will change, and everything is same as in seen incline the plane up. So this is all about the 2D.